Let's solve another problem on the anti-coordinate system, and yeah, let's start that. And in this problem, it's given that a particle is moving on a path that is given by this equation: y is equal to 10 times ln x. Okay, ln is log to base e. And then there could be many questions. For example, what could be the acceleration of a particle at a given point, like that. But what we are trying to discuss in this problem is, see, if you write the general expression for the acceleration, so this is the tangential part, and this is the normal part, right? And as we said, these things will come from the speedometer data, but all the other things, so these are coming from the map. Okay, so these are coming from the map or the road. Okay, now in this problem, the road is given basically by this equation. So, and then depending on a different problem, these things could be given in some way or the other, but we are now concerned with finding out these three terms because only the path is given. For that, what we will do, so we will first try to draw the curve, the path. So this is something like this, the x-axis and the y-axis, and then your ln x curve looks something like this, isn't it? This is 10 ln x, and suppose you are asked to figure out what is the acceleration at point, say, A. Okay, just this much is given. Then you have to find out this et. Maybe it will look something like this. Okay, et. Then en, which will be, say, perpendicular to this, and then what is the radius of curvature in that particular location. Okay, so these are the three things. Let's try to find out. Once you figure these things out, you can solve for any acceleration problem. Now, where do you think the curve will cross the x-axis? It will be at x is equal to 1, right? So at this point, x is equal to 1. So there the log will take the value of 0. Okay. Now, we know that for 2D curves, the formula for the radius, right? So we have this 1 plus dy over dx, it's squared, whole raised to 3 by 2 or by d square y by dx square. Fine. In fact, we are more interested in the mod of that. Fine. The absolute value of the radius, not in the positivity or negativity of the radius. Now, so then what is the value of dy by dx at x is equal to 1? So that is the point A. So which will be equal to 10 over x, right, which is equal to 10. Similarly, what is the value of d square y by dx square at x is equal to 1? So that will be, if we differentiate this, we will get minus 10 over x squared, and at x equal to 1 we will get again minus 10. So if you substitute these values over here, okay, so substitute this value here and this value here, and you will get r to be equal to 101.5 meters. Okay, so that is done. Now how to figure out ET and EN? So these are the two other things which we are asked to find out. Now see, this ET, it has got a length of 1 unit, right? So just we need to find out then this angle theta. I'll draw with this. Okay, if this angle theta is known, then everything can be figured out. Now how much is that? So that so tan of theta is nothing but dy over dx, right? So if I want to calculate tan of theta at x is equal to 1, then dy by dx at x is equal to 1, I have to evaluate, which we have already figured out that it is 10. So theta will be nothing but tan inverse of 10, which is around 84.3 degrees. Fine. Then everything is clear. Now let's say what is ET. So ET, you see here, if I draw a perpendicular here, so this part is ET cos I component, and this is the J component, right? So one cos theta and one sin theta. So this is equal to cos of 84.3 degree times I plus sine of 84.3 degrees times J. Okay, so which will come out to be 0.0995 I plus 0.9, sorry, point here, 95 J. Okay. Similarly, if you want to calculate En, so that will be, you see here, I'll draw like this. So this is this portion, and this is this. So this is 1 of sine of 84 degree, which is in the negative direction. So this is I'll say cosine of something is wrong. Okay, I should have written sine of. If I want to use the same angle 84, then it should be sine of 84.3 degrees in the I direction, because now this angle is 84. Okay, so I minus cosine of 84.3 degrees is equal to 0.995 I minus 0.0995 J. So that is how you should calculate the values of ET, EN and R. So which are the parameters which can be figured out from the nature of the path itself, and that's the crux of the NT-coordinate system. Fine. So yeah, so we will stop here and we will see another problem in the next video. Thank you.